Okay, today we continue. We also have another queue called the priority queue. Okay. What's a priority queue? We discussed yesterday. We prioritize every time to insert the value, the other priority. Okay. So if just for numerical insert, right, into the queue, they usually to add a sorting algorithm. Okay, inside the queue, either ascending or descending. Okay, but here we talk about ascending for this type of the priority queue. Okay, for today on the lecture. Also, there's some another scenarios. They assign the priority separately. Okay, for example, you put not a numerical, it's A, B, C or something, some other scenario. You can using the pair, right? Paired up. Okay, this value attached with kind of priority, and then they be sorted by the priority inside the queue. All right. Okay. All right. Let's look at the code. Okay, take a minute to look at this code. Example, let's do in the in queue 50. Okay, the value 50. Okay. And pretty straightforward, right? We put 50 into the vector. And then we put 30, in queue 30. And then how it works here? 30 will be what? They're going to get the iterator from beginning. They compare, okay? Compare. And then reordered, okay? If this the value 30 greater than the beginning, they continue. Otherwise, they step out. Okay, so because this is less than 8, so they continue one more time until the end. The end means what? Means the dereference. Okay, it's not a point to the last elements of iterator. Okay, we mentioned about before, right? Equal to end. Okay, dereference. And then we do what? We insert, okay? We do insert here, all right? Okay, for 40. We do the 40, in queue 40. What do we here? We have 40, right? And then we're going to compare. Where's the beginning? 30. And then 30, and we 30 greater than, 40 greater than 30, okay? Greater than 30, we can do iterate one more time, and we find 50 greater than 40, and we're going to insert in this position. Okay, become like that. Okay, now it's being sorted. Once to in queue, every time you in queue a new value. In queue 60 now. We loop over, right? Continue loop until where? Until the end. Okay, until the end. If the iterator equal to the place for dereference equal to end, they jump out of while loop and to insert at the end. Okay, makes sense, right? Okay. Deque. What is Deque? Grab the first one, right? Okay. 30 is gone, right? So let's check whether it's empty or not. Otherwise, we want to know what value on the front, right? The first value. We use the date front, okay, and get the value, and then we remove this iterator and return the value. We do it again. Return 40, right? Okay. All right. Okay. So in queue and deque, 34, right? Okay. All right. Let's look at. This is a pretty straightforward pick function, right? Just return the front value, the value of front, right? Check whether empty or not. Whether this vector is empty, using the built-in function for vector. To display, we just do an iterator to show all the value inside the queue. Okay. Now let's look at the solution for linked list. For example, to in Q50, right? On the in Q50, there's no node, okay, on this queue yet. So we declare the new node, right? 50 also have the pointer, nice pointer. So there's no head being initialized. So the head will be none, okay? None, so this is what? True, okay? This is true that go here. So because it's just a single node, the new node nest will be equal to head, means equal to non-pointer. Okay, it's a single node here. And we need to set the head into this new node. Okay? That's the first element you are in queue into the priority queue. Okay, make sense? Okay, let's do another one to 30. Okay, we have another new node created, right? For 30. Now the head is not none, right? The head point to this element. So not head equal to false, but we need to check this condition as well, this OR condition as well, okay? So we want to compare with the value, whether it's less than head data, whether it's less than this or not, okay? If it's less, we go inside, okay? So it means insert into the front, okay? This is true, right? This is true, okay? So this is OR, right? But either OR is true, we go inside. So this new node nest point to the head. Let's point to a head, okay? And the head going to change it to where? To here. Okay, that's about. Okay, the first two, I was confused on Tuesday. Sorry about that. But I was understand during my prepared lecture, but during the lecture, but somehow, yeah. Okay, let's keep going, right? In code 40. Let's check the 40. Our new node, the value in the 40. So the head, this is false, right? Because head already point some nodes. It's now none, right? What about this one? The value is less than head data or not? It's a great, right? So it's false. So it won't go here. We won't go here. Okay. So it means this, even though we do the in queue, but this not insert where? In the front. Okay. They want to compare to do the to send the prioritize to the sending, right? And we go here, right? Okay. Let's go here. We declare the current equal to head, okay? And then we doing the while loop, want to compare which position for this node to insert, right? So we can compare from head for each of a node, all right? So the current nest is now none, it means it's not last element, right? And the current nest data less or equal to what? This is a great equal than this value. Let's move forward. For example, here, right? This one current nest is now none, and the current nest, this one, right? Data 40 is what? It's 50 is a greater than 40. Okay, so they won't go here. Make sense? What they do here? New node nest equal to current nest. New node nest equal to current nest, okay? And the current nest equal to a new node. Current nest equal to new node. Do one more time for 60. 60 in this case, for 60, okay? This won't go this loop, okay? And what about this one? They're going to start while loop, okay? Until when? Until the next data, until the next. In this case, the current nest equal to what? Equal to none, so they jump out because it insert in the last position. But if in the middle of the queue, will be determine this value, okay? No, this condition. All right, they go here, what do here? Okay, we create what? So the current will go to the last one, go to the last because it loop over. And the new node nest equal to current nest. What the current nest? It's none, right? We need to assign the new node nest equal to none. It means what? Last element, okay? And then we go current nest equal to the new node. So this done. Okay, let's do the decode here though. Doing the decode. So on the decode, what do we do here? For example, if we have a decode, doing the DQ. If we're doing a DQ, we should return this node, value of node, right? And delink this node. Okay, let's look at here. First, we have the variable for the head of data. Okay, this is the front, right? Head of data. The value, we keep this value, and then we have the temporary pointers point to the head. So the head equal to head nest. So the head we're going to change it to here, right? And we're going to delay this pointer. It's being delayed. So that's finishes the DQ, okay? We're going to return what? Return the 30. Okay? Yeah, I will review in-queue for this part. Okay. Questions so far regarding for the linked list? Okay, let's quick look at the peak. Peak just returns the head of the value, right? Head data, pretty straightforward. Check whether empty or not. We can check whether head is point to a non-pointer or not. To display, it's going to do the iterator. Do the loop, okay? Do the loop, have a while loop to display each value of the node, okay? From the head until the end. Any questions so far? Okay. All right, okay, let's see any example we're using priority queue. Any example, think to use priority queue? In the hospital, right? Hospital, we're using the queue, but it's not fully like the first come, first service, right? So it's based on what the severance of this patient. They have to assign the priority, whether they have this patient in the very severe issue or not. If you don't have a very emergency case, they put you, even though you come early, but they still put you later, right? Airport landing queue. Okay. Airport landing queue probably is based on schedule. Once the first arrive at the airport, you can do a landing. But some cases, it's not the case, right? If any emergency happened, right? For example, the airplane just take off, but have the medical emergency regarding for the passenger, you have to landing. So they have to be high priority to landing, right? Boarding as well, right? Boarding, even though we come to the gate, right? Maybe around same, we come to a gate. Everyone come to a gate, but based on the zone, assign the zone on your ticket, right? Also based on whether you're premium or VIP guest, okay? Okay, networking. How's the networking to distribute the traffic? Also based on the priorities. For example, if you are doing the conference, okay, teleconference, they probably give you the higher priority to give more traffic into teleconference. Also, they put which one is first. Put the voice first, then the video. Okay. Okay, so this is regarding for queue, the built-in function, like in C++, in Java, and Python. Okay, in the C++, they have the queue, okay? Can directly declare the queue. Java queue, they use the linked list, okay? And Python, they have the queue library to support. Look, this all the big one, okay? Looks really good, okay? For in-queue and DQ, okay, all big one. So it's very, very, very efficiency, right, to process by using the queue. For random access, so linked list provide, Okay, you can pass over the position or index. Okay, you can access the value, the elements inside the queue. But for the C++ Python, they don't provide the function to support these features. Okay, any question regarding for queue? No? Okay. Let's look at the Deque. Okay, what's a Deque? Deque is standard for what? Double and queue. Double and queue. It is a linear data structure that allows the insert or deletion on the both end. Some people treat it as a special type of a queue, but I think probably it's not quite, because it's a support like a both queue and stack feature, right? So I just want to separate topic regarding for Deque. Okay. So this is the basic operations, right? Okay. So they have the insert from front. Okay. Add elements on the front of the Deque. Insert a rear. So add elements to the rear of the Deque. Delay front. So remove and return the elements from front. Delay the rear. So it's going to return and remove and return the elements from rear. Get front. It's just return the front elements without remove it. Get rear, return the rear elements without remove it. Is empty is a boolean to check whether the Deque is empty or not. Is full. It's just for fixed size Deque, check whether Deque is full or not. Size is return the number of elements in the current Deque. Clear, going to remove all the elements on the Deque. Okay, these are basic operations. We focus on this part. Okay. Okay, type of a queue. First, general queue is double and queue. You can do the insertion by both front and rear, deletion by both front and rear. Okay, so this is a standard 4 feature of the Deque. Okay. Second, called the input restriction Deque. So this is insertion is allowed only in one end. Usually it's weird. Okay. Deletion is allowed to both ends. Third type is output restriction Deque. So insertion is allowed on the both end, but deletion is allowed only in one end. Deletion is usually on the front. Okay. Okay, let's look at the generic Deque. Okay, generic Deque. Okay, so this is implemented by the dynamic array. Can take a minute to look at through together. Let's do in the insert where, okay, for here. Okay. We insert the value 10, right? And then we insert where 20. Insert where, we're just using the pushback. It's for 20, we're going to push here, okay? Now let's using the insert front. Example is a 5, value is 5. Insert front, how the front works here. If the front index equal to 0, well, the vector will be insert from beginning until where? Until where? Just insert from beginning, right? From 5. Okay? If index front index equal to 0. Doing one more time. Insert front 1. So front index still 0. Will be pushed where? Push into front. Okay? Let's process the delay front. Once we delay the front, this is not empty. What do you do here? Front index plus 1. Front index equal to here. Okay? What? Anyone have a question? No? Okay. delay rear. Okay, let's look at here. Delay rear is not empty, doing a buffer, pump back. Okay, 20 is gone. Okay. So for insert here, we use the vector insert. Before we talk about insert, right? The complexity is O, right? Big O of n. So big O of n is okay, but is there any way to improve? Is there any way to improve? Yesterday, what we learned was using the circular Q. Circular Q insert is what? O1, amortized 1. If not resized. If resized, will become the n, right? But it's better than big O of n. Okay? So we can implement the Deque by dynamic array, by the circular Q as well. Okay? Circular Q. Okay, let's look at the code. How to using circular Q to implement the Deque. First, let's doing the insert where for at the value at 10. So what we do here? If the let's go here. So the count is what? It's initialize the count is 0, right? So it's not equal to a capacity. We don't resize. The initialize is 4, so now we don't resize. So the vector where which position? This position, right? Put a 10 here, and then the where will be changed to from 0 to at 1. Count plus count equal to 1. Let's insert one more from where, right? Where 20. Okay, what they do here? So it's still not equal to capacity. We don't need to resize, and the position where here will be inserted into 20, and we're going to using the mode where +1, we calculate from here, right? Plus capacity 4 mode by 4, so it's what 1 plus 1 mode by 1 plus 1 plus 1 plus 1 equal to 2. 2 plus 4, 6 mode by 4 equal to 2, right? So we're changing to put one more, okay? Go to here. Count will be increased one more time. Count equal to 2. So the front is nothing changed, right? Still keep in 0. Okay, let's do in the insert. Insert front, for example, insert for 5. We're doing insert here. So the count is 3, right? It's not equal to 4. The capacity is 4. We don't resize. Front equal to mode. Front 0 minus 1. It's a minus 1 pass over to this function. Minus 1 plus capacity 4 equal to 3 mode by 4. It's a position at 3. Okay. This is a position at 3. Okay. So the front be moved to position at 3. Where not change, still 2. Count, still 3. Confused, right? Start confused. Okay. Let's do another insert where 30. Okay. Let's see how it works. Okay. So front equal to 3, but on insert where it's nothing to do with front. Okay. So we care about what? Only care about the index of where. Okay. So count equal to 3 so far. We don't need resize. And where 2, right? Here's 2. We put a 30 in here, right? Okay. And we're being increment one more, right? Where +1, where +1, 2 plus 1, 3. 3 plus 4 mode by 4 equal to 3. Okay. Where on where point to here, point to the front here. count equal to 4. Okay? This is how the Deque on the dynamic array using circular queue. What about insert 40? We're going to resize, right? On the resize, which we see on the from yesterday, right? Resize function. We need to copy, doing the copy, double size and copy. Once we do the copy, this will be reorganized. Okay. Okay. So this regarding for delay front, delay where. This is very straightforward. Okay. So if it's empty, it's return. If not, we what? We just remove. We just move the front. Okay. Move one more step for front, and count minus minus. So the count mainly to define the size of the circular queue. Okay. Delay where is where minus 1. Okay. Using mode function where minus 1, and count will be minus minus. Okay. We move a bit. Okay. Get front. We just return the buffer or vector on the front on the front index. Get where will be returned the place for the where index. Okay. Display we just loop over to display each of the elements inside the circular queue. Okay. All right. Okay. Let's look at how to implement the linked list. Linked list will be much more easier to implement the Deque. So Deque is mainly for both ends, right? What do you think which type of a linked list using best fit? Doubly, right? Doubly, yeah. Double linked list. We use double linked list. Yeah, you can see the code already, right? So you have a pures and nest. So it's a doubly, okay? So this we declare the structures for double linked list. This note, right? Pures nest also have the value attached, okay? This is to construction, right? To construction the double linked list. Okay, let's take a minute. Let's look at this code. Okay. Let's walk through together. Okay, let's insert front 10. We go this function. We have a new node. Okay, declare at 10. We have a pures and nest. Okay. If this is empty, we're just using front equal to where equal to this new node. Define the front and where. Okay. One more insert to 20. Okay, we have the new node of the values 20. So this is not empty. We go here. New node nest, right? Nest, we point into the front. This is the front. Front pures, right? Point to the new node. And the front equal to new node. So the front change it to here. Okay? And the count plus plus. Oh. That's doing the insert where. Okay, we go through from this function. We have a new node, value is 5. Okay, this is not empty. We go here. So new node purely point to where? Point to rear. Okay, point to this one. Where nest point to the new node. We change the position to where into the new node. And then increase the size, because that's being increased. Doing one more, insert where 25. Okay, so on this new node, pures point to the where, okay? And then where nest point to the new node. Change the position to where into the new node. Size increased. Okay? Yeah. Any questions so far for this one? Easy, right? Okay, good though. Okay, so yeah, take a minute to look at how to delay the front, delay the rear. Okay, let's walk through together. Okay. All right. Okay. Once we do the delay front, so this is not empty. We go here, create the pointer, temporary pointer, point to the front node. Okay. Front will be equal to front nest. What a nest is this one, right? So we change the position for this one to this node. Okay. If front is what? It's not none, have a value, right? Front nest go to front purest go to none. Front purest will be going to break this relation, okay? Relationship. This is gone. All right. And then we do what? Delay the temporary node and reduce the size by 1. Okay. Doing the delay where, okay? So this is a Deque, it's not none. We create a pointer, temporary pointer, point to this node. Okay. Where purest, right? They move the where position from here to here. Okay. And where is not none, so where nest is non-pointer. So it means this will be gone. We break this relationship between these two nodes. Okay, and then delay the temporary, delay this one, right? This node, and reduce the size count, minus count. Okay, reduce by 1. Okay, let's do it again. Delay front. Okay, we create a temporary pointer for front for this node. We move the front into here, okay, and then delay, disconnecting this relationship, okay, and then delay this node. Size reduced by 1. Delay rear again. What do we do here? This is not equal to empty. So what? Temporarily create temporary pointer, point to this node. Okay. Where equal to where purest. Where equal to where purest. Where being released. Okay. Purest is none, right? So it means where going to be, this is being released. If where it's equal to none, what do we do here? We're not going to here, we do here. Okay? We have to release the front pointers. Okay? Front is gone. And then we're going to safely to delay the temporary pointer, delay this node, and reduce the size by 1. Okay? We have to handle this 2 pointer, front and rear, properly. Yeah. If we want, if the Deque is empty, we have to release the 2 pointer. I'll try to avoid the dangling pointer. Okay? Question? No? Good. Okay. Yeah. Let's let's go through this. It's pretty straightforward. Okay. Get front, we just return the front value. Okay. Get rear, we just return the rear value. Display, just loop over to display all the value into a Deque. Okay, any question regarding for the double linked list?